Welcome back, guys. We have one more plate to go over and a couple of new tubes that we haven't seen before. So let's jump into it. What our next test is an AMYLASE test using STARCH agar. All right. So sometimes they'll say it's the STARCH agar plate. Sometimes they'll say we're doing an AMYLASE test. You'll want to know that they're basically the same thing. All right, and it looks here, if you look at the top left, this is an uninoculated starch plate. Okay, so, and what makes it a starch plate, because it looks a lot like a TSA plate, doesn't it? What they've added to this particular plate is starch. All right, it's just that starch is not easy to see, and it looks just like a TSA plate here on the left. All right, so uninoculated, labeled A, that's a starch plate. Now, if we were to do nothing to that plate, not put any organism on at all, but pour a little bit of iodine on top of it and let it sit for a few minutes, which is what we see here in B, we would find that it would change color. Okay, it would change to this dark, kind of almost like a black color, and sometimes it takes on kind of a dark purple color, but it's going to take on this dark color, and this would indicate that starch is still in there and it's really concentrated. All right, so now we come along and we take this starch plate and we inoculate that plate. Now here in the bottom left, they've done that. They haven't done a streak plate. If they were, they did a pretty bad job of it, right? Because I don't see any isolated colonies. But they did scribble the organism out here, and this was then incubated for probably at 37 degrees for a day or so. And before any iodine was applied to this plate, this is what it looks like. So a day after it went in the incubator, this is what it looked like. And then they added iodine to this plate over here in the bottom right. Let it sit for I think it's 3 to 5 minutes. Pour that iodine off into the sink, rinse it down, and this is what you'd end up seeing here. You'd see this halo, this clearing that happens to be around that squiggle there, that growth that occurred. And that is indicating to us that the starch that was once in those zones, and that kind of clearing that occurred, that starch is gone. It's been eaten away by something called AMYLASE. All right. So the key ingredient here would be starch in the plate. This is not going to stop anything from growing, this plate. It's not selective. There's nothing there that's particularly bad that would kill any particular group of organisms. But it is differential, which means that it's either going to show this halo or it's not. All right? So this would be an amylase positive result. It's definitely an amylase producer, and that enzyme was secreted and ate up all the carbohydrate around. All right? Here we have another image in the top here where we have growth after coming out of the incubator, but before the iodine was applied. And then here we have after the iodine was applied. And you do not see that halo. It has to be an amylase negative result. Now on the bottom here we see two lines. So a sterilized instrument was used to grab a little bit, an inoculum, right, a little sample of one organism on the left, sterilized, grab another sample from a different organism on the left, or on the right, excuse me. Okay, so over here, and the organism on the right does not seem to have any kind of halo, right? So we'd say this is an amylase negative result here on the bottom right, and we say that this is an amylase positive result on the bottom left. Okay, we also have a couple of brand new types of medium that they're not brand new really, but they're just looking very different in the tubes that we see here. We have talked about broth, where the broth is liquid in a tube and it's just, sloshes around like a liquid will. And we've already seen a solid medium with agar in it, right, and plates. Well, these particular tests are often done in a tube, but it's with agar mixed into the broth. Okay, so they're going to solidify at room temperature. And if before we let it solidify, we tilt these tubes at an angle, all right, so we pour the broth in there with the agar and we let it solidify at an angle, what will happen is the medium will actually, like jello, right, at a certain angle, it'll all kind of solidify in that arrangement. And that's called a slant, okay? So these are just agar slants. Nothing special about them other than they're in these little tubes and it's just agar in a tube rather than a plate. Now inside of these media, we have citrate. So this is a carbon source. It can be a carbon source for some organisms. And we have bromothymol blue, which is a pH indicator. So we see a lot of pH indicators and we want to know what they do, guys. Phenol red changed from red to yellow when it was acidic. Neutral red did not change to yellow. In fact, it got more of a kind of a bright purple pink color, right? Now, when we look at bromothymol blue, it's very different pH indicator. This particular medium is selective. All right, so there's going to be an inability for some organisms to grow using citrate as its sole carbon source. There's nothing killing the organisms in this selective medium, like in the others. It's just that some organisms cannot grow on citrate, and that's all that we that's all that we put into this medium. There are no other sugars to grow on. All right, so this will inhibit organisms that are unable to utilize citrate as their sole carbon source. Now here you can see what they've done is that they've gone in with a sterilized instrument with a little bit of inoculum, so a little bit of organism on their instrument, and they just kind of squiggle back and forth. You can kind of see it here, right? That trace. So they have inoculated this plate, or this slant, put it in the incubator, and this is what they got with this left-hand tube. Looks just like the uninoculated tube. It's green going in, and it's green coming out. Nothing grew, nothing changed color. All right? So this would be a citrate negative result. It was unable to utilize citrate as its sole carbon source. Now, if we have an organism that does grow, and here you can see the growth here on this particular slant, right? So you can kind of see where the line is that they squiggled their inoculum on here, and you see that it's thicker than just a line, right? So this actually did kind of spread out a little bit. It grew, and just to kind of hit that idea home that it grew, we got the color change. We have a pH change. Now, the difference here is usually with the pH change, there are acidic byproducts. The medium gets more acidic and the pH indicator changes its color. In this case, the medium actually becomes more basic, a more alkaline environment. And with a more alkaline environment, bromothymol blue is really blue. Okay? So here with the blue color change, we have a citrate positive result, meaning that the citrate was used, and we have some basic products. A little bit of a twist, right, compared to what we've seen before. So here we have an example, right? Here we have and not inoculated, so uninoculated sample on the very left, right? Looked green like we expect. We have this organism called Proteus mirabilis, which is also green. Looks to me like nothing happened. No growth, green medium, citrate negative result, okay? Now this one over here, Klebsiella pneumonia, this one clearly has some blue color, right? Now I can't see the growth here, but we know it grew, right? As soon as we see a color change like that, there's no doubt that it grew, right? Because otherwise, if it wasn't able to grow and utilize that citrate, you wouldn't see the color change, okay? So this would be a citrate positive result here on the right. All right, let's see. Our last slant, we have two slants to talk about, okay? This is a UREASE assay or UREASE test, and they'll use urea AGAR to test this. So quite literally, there's urea in here, okay? Now, we think of urea as a waste product, but organisms can utilize urea and to get something out of it. So here we're testing for the use of urea, the production of an enzyme called UREASE to enable an organism to get some benefit from urea. Now here on the left we see an uninoculated tube. This uninoculated tube has kind of a yellowish color to it. What's in there? Well, it's got urea. Well, that kind of makes sense, right, if it's yellow. And it's got a phenol red indicator in there. Now, phenol red. Let's see. Now, phenol red, back in our plates, phenol red would change yellow when it's acidic. So we have an interesting situation here where it's starting out with kind of a yellowish color, all right? Now, over here on the right, we've got organisms that were kind of scribbled out on these slants. We've got one that's showing a really hot pink color going on, all up and down that slant. We have another one that's showing a hot pink color at the top, not so pink at the bottom, but definitely there's a color change. And then we have this other one over on the very right that's looking just like the original, right? Well, if it's looking just like the original, chances are there's nothing that happened, right? There were no changes that occurred. And that would be absolutely the case. There is no change. There is no urease production and use of the urea to cause any kind of pH change, okay? So no change, no urease, okay? Now, if we look at these other two, okay, so we'll use red because we got this hot pink color going on. If we look at these other two here, we'll call them A and B, okay? C, we already know that's a urease negative. So if we look at A and B here, we definitely had some color change. If we see any kind of hot pink color produced, we know that urease was produced. Urease broke down urea in these media and ended up producing a basic product. Okay, so this is the second of two media that do not produce acidic byproducts. The only two in all of the media that we have to know. Okay, so what happens to phenol red when it's basic? Well, it changes to this really hot pink color. It's not just red, that's more of a neutral color. It changes to a hot pink color, okay? And that's what you're seeing here. So whether you have hot pink all the way through or hot pink just on the top, we would say it's urease positive. The difference between these two A and B, is what allows us to call this differential medium. They grew on A and B, but they grew a little bit differently in that there was a lot of urease over on the left with A, and there's not as much urease with B. Some organisms are prolific about their production of enzymes like urease with A, and some are not. They get a little bit of a slow start with the production of urease. All right, so I think that's good enough for now, and all we have left are some carbohydrate fermentation tubes, and we're done with our media. Okay.